What's up, mathematicians? Justin here, and welcome to unit number 2. That's right, we are starting a new unit, and this unit will be called logic. In unit number 1, we studied measurement, and we ended the unit with this question of how we could prove that the angle sum of a triangle is 180 degrees. In order to work up to this proof, we need an important tool, and that tool is logic. So in this unit, we will talk about logic. This is our first lesson in this unit on logic. I'm calling this lesson Logic and the Art of Knowing. And I'd like to start out by sharing a photo with you. Check this photo out. Okay, so when I was in college, this photo was going around and people were making a big deal out of it, saying, wow, look at this crazy photo. Isn't it amazing? Now, probably not surprisingly to you watching this now, it came out later that this photo was a fake. I mean, come on. Could you not see that coming? But in fact, actually, there's an alternate version I thought I'd share with you because I think it's kind of funny. I think this might be photoshopped. Just a hunch there. But the reason that I bring up this photo is I want to think about how we would know that the photo was real or fake. And moreover, how do we actually know anything? Clearly, that shark photo was fake news. But how do we know when something is true? And what does it even mean to know something? So this is really more of a philosophical question than a mathematical question per se. And if we consider the tradition of mainstream Western philosophy, this pursuit is largely rooted in the ancient Greeks. So there are a couple Greek philosophers named Socrates and Plato, pictured here, at least sculptures of them, pictured here. And these philosophers believed that the way to know things was through dialogue and argument and discussion, that these were the essential tools for accessing and advancing our understanding of truth, for coming to know things with certainty. So one problem is that this dialectic approach can be subverted relatively easily. We see this all the time with things like PR information, aka propaganda, put out by corporations and politicians, as well as politically skewed news coverage. But this was also an issue in the time of Socrates and Plato, when the sophists were notorious for at least having this reputation for trying to win arguments by any means necessary, regardless of whether the truth was on their side or not. In the modern day, we often accuse lawyers and politicians of this kind of behavior. However, unlike lawyers and politicians, for some reason, we seem to universally trust what mathematicians tell us. Why? Why is it that mathematics is seen as being so trustworthy? What does mathematics have going for it that causes it to be seen as so reliable and universal? In a word, logic. Mathematics has this ability to help us know things and agree on things, an ability that has resulted in amazing progress in the development of mathematics, an ability, I would point out, that is rooted in logic. I want to share a quote with you here, and here we go. So this quote is from a book called The Art of Logic by Eugenia Chang, and she says in the book, the idea of logic is to have clear rules so that conclusions can be drawn unambiguously and consistently by different people. Why are mathematicians able to reach agreements about what is true? And why do those things remain true thousands of years later, where other subjects appear to be continually refining and updating their theories? I believe the answer lies in the robustness of logic. That is its great advantage. So yeah, as I mentioned, that is a quote from this book right here, The Art of Logic by Eugenia Chang. But I want to dig a little deeper into this idea of conclusions that can be drawn unambiguously and consistently by different people. So one current hot button issue political issue here in the United States is the issue of abortion. And the conclusions that people typically draw on this issue of abortion tend to be heavily influenced by things like their personal beliefs or the beliefs of those around them, religious affiliations, and political persuasion. As a result, if we talk about a current issue happening right now, as I'm making this video, with Texas passing legislation restricting women's abortion rights, we do not have a situation where conclusions are able to be drawn unambiguously and consistently by different people. And by different people, I mean people of all different beliefs, all different religions and political persuasions, right? Whether or not you believe that the angle sum of a triangle is 180 degrees, as we're trying to get up to the proof of in this course, whether or not you believe that's true doesn't, I don't think, depend on your political beliefs. However, whether or not you believe that Texas's new abortion laws are justified probably does. So we end up in this situation where one group of people over here knows that something is wrong, and another group of people over here knows that that same thing is right. How does this happen, and what can we do about it? Could math possibly come to our rescue? Maybe? I don't know. I don't want to get your hopes up here. These questions are very complex and involved, and far more than I am able to fully address in this video or, frankly, this lifetime. One of the main things, though, going on is that different people are starting from different assumptions or beliefs. And that's an idea we'll explore further toward the end of the unit when we talk about axiomatic systems. But at this point, I'll just say that so long as different people, and wait, I have a little graphic for this here. Let me pull it up. So I'll just state that so long as different people start from the same beliefs and assumptions, then apply logic correctly, they will always come to and agree on the same conclusion. That is the power of logic. So to further illustrate this point, I'll share a conversation I had recently with a colleague. We were talking about data related to things like global warming and the melting of the polar ice cap, and he was lamenting that it seems like in our modern American society, many people just don't seem to trust data and statistics, which might suggest that maybe they don't really trust mathematics, since statistics is considered to be a branch of mathematics. However, I think the thing that people don't really trust is not the data, not the statistics or mathematics, but rather the source of the data. Okay, so imagine, just in your head, imagine that you took a very conservative Republican and a very liberal Democrat. There is a good chance the two would have disagreements about things related to climate change, the thing that we were discussing data about. However, their disagreements would not be about the nature of data and statistics itself. Rather, the disagreements would likely be reflections on the amount of trust that they have in different sources of information. Okay, so imagine now that you took these same two people, your conservative Republican, your liberal Democrat, you put them on the side of a not too busy street, and you asked them both to count the number of cars that passed by on the street, and also to keep track of the number of red cars. Then you ask them to calculate the percentage of cars that passed by that were red. Now, assuming that both people counted correctly and had sufficient knowledge of mathematics and were not colorblind, they would both come to the exact same conclusion about the percentage of cars that passed by that were red. They would both agree on the counting numbers, 1, 2, 3, etc., and what these numbers represent. They would also agree, if they had sufficient knowledge of mathematics, that this formula right here, let me pull it up, where is it? There we go, that the number of red cars, the percentage of red cars is equal to the number of red cars divided by the number of total cars. They would agree that this is the correct formula for determining the percentage of red cars. So by agreeing on those things, proper use of counting numbers and this formula, they would come to the exact same percentage. And this is regardless of political persuasion or personal belief. Okay? That is the power of mathematics for enabling us to know things with certainty and to agree on things. And what I'm saying in this lesson is that power is rooted in logic. So this brings me to one of my favorite definitions for mathematics, which, still a work in progress, but I'll throw it up here. So one of my favorite definitions of mathematics is this. Mathematics is the study of any relationships or structures to which deductive logic can be applied. To the extent that we can use deductive logic in studying issues of justice, politics, music, art, science, parenting, philosophy, psychology, etc., we are actually doing mathematics. Disagreements in these fields are not about the logic, but they are about the accepted facts, beliefs, and underlying assumptions. We all believe in the logic, but since we start from different places, the logic, even when properly applied, gives us different conclusions. But what is deductive logic? Is it the only type of logic? How can we properly apply it? What are the rules of deductive logic? Well, that's what this unit is all about. So in line with what Eugenia Chang said in the quote I shared earlier, I would claim that deductive logic is first and foremost a set of rules which can be used to discover and verify new things based on things already known or believed, things that were previously observed, assumed, or proven. More simply, logic is a tool that we can use to know things. But thinking of it that way is really being overly simplistic, right? Because logic is, of course, not the only tool we can use to know things. For example, we can discover new things through observation. But to use terminology from Immanuel Kant, logic is a way to advance our knowledge a priori, which means a way to discover new things without needing new observations or experiences. Just by using our brain and following the rules of deductive logic, we can find out new stuff. We can create new knowledge. I think that is pretty exciting. In the rest of this unit, we will explore some of the rules of deductive logic, and we will look at techniques and some examples for applying it. In the next video, we'll look at a fun activity which will help give you a sense of what deductive logic can feel like. Thank you so much for watching, and we'll see you then.